Kia ora Year 12. Here are the last three parts from question 2 of the 2015 Algebra exam. So apologies in advance, this is going to be a little bit longer because there are 3 excellence questions in here and I'm going to go reasonably slowly with them. Alright, here's the first one, which is to solve this equation. So let's just write it out again because that always makes everything feel a bit better. We look at that and it doesn't look particularly nice, but then remember that basically all we know how to solve at level 2 is a quadratic equation or a linear equation. So this has got to fit into a quadratic pattern. And once you've seen this, they're really, really easy. We're going to make a substitution. We're going to say let x equal u to the power of 1/3. I'm doing that because this is u to the power of 1/3, which is going to be like my x term in my quadratic, and this is u to the power of 2/3. Okay, so really, really slowly on that, u to the power of 2/3 is equal to u to the power of 1/3 squared. Right, so once I make that substitution, here's what I get. 2x squared plus 7x equals 4. And if you've just done question 2a, which was in an earlier video, you'll recognise that quadratic. It was part of our easy achieved question 2a. Okay, so we're going to solve this now on the next slide. Okay, so we get 2x squared plus 7x minus 4 equals 0. Let's see, what does that give us? Well, we're going to have 2x and x here, and we'll have 2x minus 1 and plus 4. Right, if you're having trouble factorising that, you need to go back and watch the earlier video. Right, that gives us 2 possible solutions. We've got 2x equals 1 or x equals negative 4. So now we need to go back and say, well, if x equals 1/2, x is the cube root of u, or u to the power of 1/3. So u to the power of 1/3 equals 1/2. What am I going to do to figure out u? Well, I can undo the cube rooting by cubing both sides. That leaves me with u equals 1/8. So that's one solution. And the other one is this. So x is equal to negative 4. X is the same as u to the power of 1/3. So same thing again. Cube both sides and we'll get u is equal to negative 64. Okay, so now that all looks good. There's just one more thing we need to do. And we do it sporadically when we're doing any equation. But once we start working with more tricky equations, we need to really check that both of those solutions are true, that they're valid. So I'm going to take a new slide to do that. And we're going to substitute each of these back into the original equation and just make sure that they really do work. So we're looking at whether the values we've come up with do satisfy this equation. So let's check if u equals 1/8, does it work? Well, we've got 2 times 1/8 to the power of 2/3 plus 7 times 1/8 to the power of 1/3. So that's equal to 2 times, well, this is, I know some of you are going to do this on your calculator, but this is 1/2 squared plus 7 times 1/2, which equals 2/4 plus 7/2, which is 4 as required. Okay, and I'm going to do the same thing now with our other solution, which is u equals negative 64. So we're happy, we've shown that our first solution really is a solution, not just a possible solution. Now we're going to check this one. So 2u to the power of 2/3 plus 7u to the power of 1/3. What's that? Well, 2 times this plus 7 times this. Right, this is 2 times, well, the cube root of negative 64 is 4, negative 4. So it's going to be that plus 7 times negative 4. Now, I don't know why they'll put 16 up there. That should say, if you're sitting there watching wondering what she's done, I've made a mistake. There we go. So that's 2 times 16 minus 28, which is indeed 4. Okay, so we've found that both the solutions are valid. So u equals negative 64 or 1/8. Now, if you're looking in the schedule for last year's paper, they didn't do that checking. And so you don't have to, but it's a really, really good habit to get into, especially if you're heading into level 3 calculus next year. Okay, on to part D. Right, Talia used timber to form the exterior sides of her rectangular garden. So we'll start off by drawing the rectangular garden. The length of the garden is x metres, and its area is 50 metres. This is an achieved part before we get on to a harder one. Show that the perimeter of the garden is given by this expression here. Well, we know that area is equal to length times width, so that equals x times w. We'll mark w, the width of the garden, on there. We should really write out let w be the width of the garden, but we might not do that. We know that the area is 50, so 50 equals x times w, so the width must be 50 over x. So now we can write p, let p be the perimeter of the garden. P is equal to the two long sides plus the two short sides, so it's going to be 2 times x plus 2 times 50 over x, and that equals 2x plus 100 over x as required. Okay, so that's that part done. Let's have a look now at the excellence part of this question. Alright, so we're told that Talia uses 33 metres of timber to build the sides. We need to find the dimensions of the garden. So the sides means the perimeter. So we've got p equals 33. We know the perimeter is 2x plus 100 over x. So this is the second example in this question, in question 2, where this equation turns out to be a quadratic. We're going to solve it by multiplying everything through by x. 33x equals 2x squared plus 100. Getting everything onto one side by subtracting 33x from both sides, I'm left with this. Now I can solve this by guess and check pretty easily. I'm going to have a 2x here and an x here. I'm doing that because I've checked there are no common factors lurking in here. So it's got to be 2x minus something and an x minus something because I'm heading for a plus 100. So I want a couple of numbers that will do that. So let's try. Just have a look and have a think. If I put a 25 here, that's going to be way too big. Let's try and put a 25 here and a 4 here and see if that works. Yep, it does. So that's 2x squared minus 25x minus 8x gets me minus 33x plus 100. I went over in the last video on the easy part of question 2 how to do that by grouping, right? So if you need a recap on grouping, go and watch that. But basically what we do is we find two numbers that multiply to give me 200, so that's A times C, and add to give me negative 33. Okay, and we proceed from there. So what we're doing when we do grouping is we're breaking up that term. Okay, now what does that give me? Two solutions, either x equals 12.5 metres or x equals 4 metres. So let's have a look at what that means, because it seems a bit strange that I'm getting out two quite different numbers. So we'll put them back into the picture of the garden and see what's going on. Okay, here's the garden. this side is 50 over x, and this is x. So if x equals 12.5, it's saying that that side is 12.5, and that side is 50 over 12.5, which is 4 metres. If instead we say, let's make x 4 metres, then the other side is 50 over 4, which is 12.5 metres. Okay, so there's a unique solution here. The dimensions of the garden are 12.5 metres and 4 metres. Okay, so that's question 2D finished. Right, now here comes the last one. And I think for most students, when they see a question like this, they kind of groan inside, but it's really not that bad if you just set your variables up right. David and Sione are competing in a cycle race of 150 metres. Alright, so Sione cycles on average 4 kilometres per hour faster than David, and he finishes half an hour earlier than David. So find David's average speed. So let's look at what we know in here. Well, we know the distance of the race is 150 kilometres, and we're looking for David's average speed. Now, we can't do any weird physics thing to solve this. We've got to do some algebra, and actually, it's quite a big help. So let David's speed, or his average speed, be x. Right? So this is the biggest thing you can do to do a word problem well in algebra, is to start by defining clearly what your variable is, and then everything else is in terms of that. So let David's average speed be x. So now I know that Sione's average speed must be, let's think about it, if he goes 4 kilometres per hour faster, which way is it going to go? Is it going to be x plus 4 or x minus 4? Well, this one's not bad, because if you think about your car, if you speed up, your speed's going to increase. So Sione's speed is faster, so his average speed is x plus 4. And we know that Sione finishes half an hour earlier than David. So the time difference is going to be 0.5. So how long does it take David to do the race? What will David's time be? Well, let's think about it. If David's average speed were 50 kilometres per hour, just suppose it's 50 kilometres per hour and he's going 150 kilometres, you'd do that easily in your head. You'd say, oh, it takes him 3 hours. So what did we do for that? Well, we did the distance, 150, divided by the speed of 50. Only we don't know his speed, it's x. So David's time is going to be given to us by 150 over x, and Sione's time is going to be 150 over x plus 4. And we know the difference between those two things is half an hour, or 0.5. So we're going to write that as an equation, and guess what? It's going to turn into a quadratic again. That's on the next slide. But actually, we've done all the hard work now. Right, so David's time is slower. So we'll put that first. 150 over x minus 150 over x plus 4 is equal to 0.5, or 1/2. Right, so let's get a common denominator here. We've got x times x plus 4. Some of you will be able to skip some of these steps, but don't skip too many, or things are likely to go bad. There we are, that equals 1/2. Right. Now we've got in the numerator here, we've got 150x here, take away 150x here, so we're left with 600 over x times x plus 4 is equal to 1/2. Cross multiplying, that gives me 1200 is equal to x times x plus 4. Right, so on the next slide we're going to finish off solving this. So we've got x squared plus 4x equals 1200. I've just switched the sides around there. And the last thing we do, because it's a quadratic, is we're going to do this. Now you look at that one for a moment and you go, ugh, not that keen on this. So it's either going to be a quadratic formula or a shove into your graphics calculator and get the answer. So I think with this one I would probably go down the calculator route. So reach for your calculator and go into Equa. Unfortunately I can't easily show you my graphics calculator with this package, but we want to go to F1 simultaneous, and we've got two unknowns. No, we haven't. We've got one unknown. Wrong one. So we're going to polynomial degree 2. Right, and we put in our A, B, and C, and it has to be in the format equals 0. So 1, 4, and negative 1200 equals 0. If you're in my class, you will know my deep loathing of graphics calculators when they're used to substitute for your brain. But in this case, it's quite good. It tells me that I've got two possible values of x. I've got 32.698 or negative 36.69. We're going to ignore that because we're dealing with speed, and so we want a positive solution. So negative answer, what a mess I'm making. Negative answer doesn't make sense. So we're going to say David's speed is 32.7 kilometres per hour. Average speed is 32.7 kilometres per hour. Sione's average speed must be 36.7 kilometres per hour. Right, but a really smart thing to do after you've put this much effort into a question would be to check that that answer is correct. So we're going to do that now, simply by going, what's 150 divided by 32.7? Because that's going to tell me how long it took David to do the race. Okay, 150 over 32.7 gives me 4.59 hours. Right, that's not 4 hours 59 minutes. And then Sione's time is 150 over 36.7, which is 4 hours 4.087. So let's get that into minutes. 0.59 times 60. So this is 4 hours and 35.4. That's for David. Sione was faster. 0.087 times 60 is 5 hours 22. So 4 hours 5 minutes. Okay, so I've rounded that a tiny bit, 0.22. But lovely, we have got almost exactly the difference that we're looking for of half an hour. All right, thanks very much for your patience. I hope that helped. Please let me know in class if you've got any more questions on that, or send me an email.